bringing this all home is our last presenter, who is Dr. Nick Smith-Sebasto from Forest Solutions. Nick, I am going to introduce you and then turn it over to you. Nick has a home base in New Jersey, and he has been in the business of working on food waste diversion for 15 years. So I am going to turn this over to you, Nick.
Hello, everybody. Thank you for taking the time out of your busy schedule to join us today. Forest Solutions provides aerobic in-vessel rotary drum composting systems that are designed based on patented biotechnology, designed to transform uneaten food into nutrient-dense, mature, stable, pathogen-free compost in just 5 days. Now, in case we need to reinforce why we need to be composting food, if you were paying attention to what happened globally last Friday, that might be all the reinforcement you need. Millions of people turned out for what they called a climate protest. Well, what does that have to do with composting? The facts are that there is no solution. Oops, I didn't mean to go forward. There's no solution to climate change that doesn't include drawing carbon back down into the atmosphere. And there's no mechanism with the scale or ability or immediacy to draw down the carbon to mitigate that without restoring soil. Compost is key to sequestering carbon in the soil. Unfortunately, not all composts are created equal, so we need to think about that. And then on-site or local recovery of composting provides the greatest environmental benefits. Our systems, again, they're aerobic in-vessel rotary drum composting systems, and I do believe all those adjectives are necessary. The wonderful features about our systems are they provide virtually no unpleasant smells when properly ventilated. There's no need for any kind of biofilters. There's no methane emissions, leachate, or effluent created. They require no bacterial inoculants or enzymes. They're energy efficient, they're biologically efficient, they're very easy to operate. They have an extraordinarily small footprint relative to their processing capacities, and they're very aesthetically pleasing. Now, I mentioned they're a complete system. They're kind of like an ecosystem or a human system, and that's why we call them that. They start with the shredding system, which is the one on the bottom left-hand corner of the image. That's the loading hopper that leads to a shredder. The shredder allows us to process any food, including raw and cooked meats, dairy, fruits, vegetables, bones, and shells. And the shredder is much like the teeth in our body. It volume reduces the material so that the surface area is vastly increased for the microbial activity to occur. It's easily a quadrupling of the surface area, which is one of the reasons we're able to process the material so quickly. Additionally, we recommend as the bulking agent carbon source kiln-dried wood shavings. These are necessary to correct the moisture that's in the food. We want to take that food that's 70 to 80% water down to about 50%. It corrects the carbon-nitrogen ratio. We want the feedstock going into the digester to be somewhere around 15 or 30 to 1. And then it maintains the porosity of the feedstock once it's inside the digestion vessel. Remember, this is an aerobic process, so there needs to be space for air to be found. Again, it's a complete system, so once it goes from the digestion through the shredder, it's conveyed to the digestion vessel via a fully enclosed screw conveyor. This is very helpful to eliminate the attraction of pests, etc. And once it's inside the digestion vessel, it's a load it and forget it. Some of you might remember a fellow on TV a few years ago who had this rotisserie thing where you put the chicken in and you close the door. His tagline was set it and forget it. Well, ours is kind of load it and forget it. Once the operator has completed the load for the day, then he or she may go away and the system is fully automated. The drum will rotate as it's programmed. There will be enforced aerations as it's programmed. Our systems are designed to process anywhere from 2,500 pounds a week to 40,000 pounds a week. Now, there is a 25% reduction in the mass, and that's because water is evaporated as the interior temperatures of the digestion vessel approach 150 degrees. So there does need to be a vent to just let the moist, humid air exit the structure in which it's in. And our food to compost ratio is 1-to-1. The amount of food in equals the amount of compost out. That's because our recommendation for the bulking agent carbon source is 25% of the weight of the food, and that exactly balances what's lost through the water vapor. Again, complete composting system. So at the discharging end, there's a screener automatically that's already attached to our digestion vessel. So as the discharge port is open and the compost falls out, you end up with screened compost, because anybody who's involved with composting knows that occasionally there might be large accretions of material. When I say large, maybe the size of a ping pong ball or a golf ball, you might not necessarily want them in your compost. So only material smaller than the screen size will pass through into the receiving vessel. This is one of only 2 pieces of additional equipment that has to be purchased to go along with our composting system. One is the scale to weigh the food going in so you can calculate how much bulking agent you need, and the other is some sort of a receiving receptacle. This happens to be a trailer. And the end result is, again, mature, stable, pathogen-free, nutrient-dense compost in just 5 days. This claim has been confirmed by laboratory analyses in the U.S. at U.S. Composting Council Seal of Testing Assurance Labs, and in France with their analog. Obviously, they don't have U.S. Composting Council or ST over there, but they have their own national standards. As far as the output is concerned, this is a couple pictures of some research I conducted for the United States Environmental Protection Agency. I was asked to see what we could do about some decontaminated river sediment. And so what we did was we blended compost with that. I think maybe you can tell a difference between the two. The picture on the left is just the sediment with seeds, and the picture on the right is 50% sediment, 50% compost. These were all done in a greenhouse under strict laboratory conditions. So you see those little pieces of string. That's because we counted exactly how many seeds of grass went in there, so that everyone got the same. They all got the same water, the same sunlight, same everything. This was a picture a colleague sent to me. He put some of our food-based compost down on a golf course in October and then came back in May and saw what happened when the grass started germinating. Maybe you can detect in the picture where the compost was placed. I hope you can. Our latest installation is at Princeton University. The officials there decided, after considering all possible technologies currently available on the market, to go with a 4 Solutions Model 1000. They've got a great blog site that you can follow what's going on there as far as how much they're processing, how much they're offloading, student engagement, etc. The great thing about our systems is such a small footprint. This is a Google Earth view of the structure at Princeton University. That's a 1,000 square foot structure, and yet that system is capable of processing 260 tons per year. That equates to about 11,350 tons per acre. I offer that so that you can consider how that relates to other possible technologies. And again, it's done in 5 days. And again, if you're wondering why compost food, this is a poster that used to hang in the United States Capitol building. I saw it when I was testifying there a few years ago, and it states that composting is one of the most earth-friendly things you can do. Thank you very much for your time. Remember that ending food waste starts with you. We're here to help. Here's our email address, our website, and phone number where you can reach us.